You ever look at a word problem and your brain just shuts down? Happens to the best of us. Well, today, we're going to demystify one of those classic exam questions about seats in an auditorium. It looks kind of scary, I know, but you're about to see it's just a simple story that we can tell using a quadratic equation. Let's do this.
So here it is, the full challenge. We've got an auditorium with an original seat setup and then a new rearranged one. The big clue, the thing that connects everything, is that the total number of seats goes up by exactly 300. Our job is to use that one little fact to figure out everything else. So, yeah, let's break it down.
Here's our game plan. First, we decode the problem, turn words into math. Then, we build our equation. After that, we solve for our mystery variable, find the final answers the question is actually asking for, and finally, take a quick look back to make sure everything adds up. Let's get into it.
Okay, first things first. Honestly, the most important part of any word problem is just understanding what it's saying and translating it from English into the language of algebra. So let's pull out the most important bits of info. This sentence right here, this is the golden ticket. This is the key that unlocks the whole problem. It tells us that in the beginning, everything was perfectly symmetrical. The number of rows was the exact same as the number of seats in every single row. This is our starting point.
So, let's give our unknown a name. We'll call it x. We'll just decide that x stands for the original number of rows. But because of that key sentence we just read, x is also the number of seats in each row. See how that works? One variable, two meanings, super efficient.
This table just puts it all together nice and neat. Originally, you have x rows and x seats per row, so the total number of seats is just x times x, or x squared. Simple enough. In the new arrangement, the number of rows doubles to 2x, but each row gets 10 seats taken away, so that's x minus 10. The new total? Just multiply those two together. 2x times the quantity x minus 10. Now we have a way to talk about both situations using math.
All right, we've got our before and after expressions. Now we need to find that one piece of information that ties them together. That link is what's going to let us build the actual equation we need to solve.
And here it is. The missing link was hiding in plain sight the whole time. The total number of seats increased by 300. This isn't just a random fact. It is the mathematical bridge connecting the old auditorium to the new one.
So think about it. How do you write increased by 300 using math symbols? What does that actually mean? It means the new, bigger number minus the old, smaller number has to equal 300.
Exactly. The difference between the new total and the original total is 300. The new arrangement is just the old one plus 300 seats. So, new total minus original total equals 300. That's the blueprint for our equation.
And now we just swap in the algebraic expressions we came up with earlier. For new total seats, we write 2x times x minus 10. For original total seats, we write x squared. So, 2x times x minus 10 minus x squared equals 300. And there it is. That's our quadratic equation, all set up and ready to go. Okay, let's get down to business. We've done the hard part of translating the story. Now we just need to do the algebra to figure out what x actually is.
Let's walk through this. First, let's simplify. We multiply that 2x into the parentheses, which gets us 2x squared minus 20x. Now, to solve a quadratic, we need it in standard form, which means we want it to equal 0. So let's get everything over to the left side. We combine the 2x squared and the minus x squared, and we subtract 300 from both sides. That leaves us with x squared minus 20x minus 300 equals 0. Perfect. Now, we factor. We're looking for two numbers that multiply to get negative 300 and add to get negative 20. A little trial and error, and you'll find that negative 30 and positive 10 are our winners. We use those to split that middle term, then we factor by grouping, and what do we get? We get x minus 30 times x plus 10 equals 0. We're so close.
Now, if two things multiply to make 0, one of them has to be 0. That's the rule. So either x minus 30 is 0, which would mean x is 30, or x plus 10 is 0, which would mean x is negative 10. The math gives us two possible answers.
But hang on a second. This isn't just a math problem on a page. It's about a real auditorium with real seats. So we have to stop and ask ourselves a common sense question. Can you actually have a negative number of rows?
No, of course not. That makes zero sense in the real world. So we can just throw that negative solution right out. It's mathematically possible, but logically impossible. That leaves us with only one answer that works. X equals 30.
We found x, which is awesome, but we're not quite at the finish line. We have to go back to the original problem and make sure we answer the two specific questions it asked.
The first question was, what was the number of rows in the original arrangement? Well, hey, that's exactly what we defined x to be. So the answer to part 1 is 30. 30 rows. Easy enough, one down, one to go.
The second question asked for the total seats after the change. Remember our expression for that? It was 2x times x minus 10. All we do now is plug in the value for x that we found. So we plug in 30. That gives us 2 times 30, which is 60. And we multiply that by 30 minus 10, which is 20.
And what is 60 times 20? It's 1,200. So the total number of seats in the new arrangement is 1,200. And just like that, we've answered both questions. Now, before we celebrate, it is always a good idea to do a quick check. This is how you catch small mistakes and prove to yourself that your answers are definitely correct, because they fit the original story.
Let's just run the numbers. The original number of seats was x squared. With x being 30, that's 30 times 30, which is 900 seats. We just found that the new number of seats is 1,200. So what's the difference between 1,200 and 900? It's 300, which is exactly the number the problem gave us. It works. The check confirms our answers are spot on. Perfect.
So, to wrap it all up, this is the strategy. This is the 5-step plan you can use for so many of these problems. Read the problem and define your variable. Turn the sentences into math expressions. Find the connection that lets you build your one big equation. Solve that equation and use some common sense. And finally, go back and answer the actual questions.
Because that's the real key, isn't it? These word problems aren't just a random list of chores. They're stories. They're puzzles. And your job isn't really to be a math whiz, it's to be a good translator. To turn that story into the clean, simple language of math. Once you've done that, the answer is always just sitting there, waiting for you to find it.